Okay, so the first thing to do when doing trigonometry problems is to set your calculator to degrees. So make sure that when you turn on your calculator, press Shift, Setup and 3, so that any angles, any ratios that it gives, sine, cosine, tan, the answer is in degrees, or in reference to degrees. So the first thing we'll look at then is Pythagoras. Okay, so here's Pythagoras, and Pythagoras concerns itself with a right-angled triangle, and it basically, Pythagoras' theorem basically states that the length of the hypotenuse, which is always the side opposite the right angle in the right-angled triangle, squared, is equal to the sum of the other two sides squared. So this side squared is equal to this side squared plus that side squared. So let's look at an example of Pythagoras. If we have a golf flag casts a shadow 3 meters long, and distance from the top of the flag here to the edge of the shadow is 4 meters. How high is the flag? Okay, so what is the height h here? Well, first of all, right-angled triangle, let's name this side as the hypotenuse, and that side, which is the hypotenuse, the length of that side squared is equal to the sum of the other two sides squared. So 4 squared is 16 is equal to 9 plus h squared. H squared must be then equal to 16, bring over the minus 9. So h squared is equal to 7. So if h squared is equal to 7, then if we get the square root of both sides, the square root of h squared is h, square root of 7 is 7, and that's equal to 2.6 meters. So this flag is 2.6 meters in height. Let's now meet with the sine, cosine and tan trigonometric ratios, and these are for right-angled triangles. Okay, so when we're given a right-angled triangle, it's important that we're aware of the angle theta that we're concerned with. So in this case, it's not this angle here, it's this angle here, and that's known as theta. Okay, and with respect to this angle, we must name the sides of the triangle. This side is always the hypotenuse, opposite the right angle there. And then with respect to this angle here, this side is the side beside it or adjacent to it, and this side is the side that's opposite to the angle theta. Okay? And given that we now know which side is which, we can say that the sine of this angle in here is equal to the length of the opposite side divided by the length of the hypotenuse. The cos of this angle in here is equal to the length of the adjacent side over the length of the hypotenuse, and the tan of this angle here is equal to the opposite over the adjacent. Some old hens cackle all hours till old age. Okay, so the first type of problem we can look at is where we're given a ratio, we have to draw the triangle and then find other ratios. So we might be told that if tan theta, this angle, is equal to root 5 over 2, in other words the ratio is root 5 over 2, find the sine of theta and the cos of theta or of that angle. Okay, so the first thing with these is always to draw theta and draw the triangle around theta, okay, and then to name your side. So tan is equal to opposite over adjacent. So that must mean that the side opposite, this is the opposite, this is the adjacent, is root 5, and the side adjacent to theta is 2. So now we've drawn the triangle based and given the triangle dimensions based on this information here. Okay, here's theta, the side opposite is root 5 because tan theta is root 5 over 2, and the side adjacent is 2. Now, given these two bits of information, we can go on to find what the hypotenuse is using Pythagoras, hypotenuse squared is equal to sum of the other two side squares, and the root of any number squared is actually the number in the square root sign. So root 5 squared is root 5 by root 5 is 5. 2 squared is 4. So h squared is 9. Therefore, if we get the square root of both sides, the square root of h squared is h, and the square root of 9 is 3. So now we've set up our triangle, so we have an even fuller picture of the triangle now with all three sides, all the dimensions. We can now look to find theta, and we can say that sine of theta is equal to the opposite over the hypotenuse, so that's root 5 over 3, because some opposite, hence opposite over hypotenuse is root 5 over 3, and the cos of theta is the adjacent over the hypotenuse is 2 over 3. Okay, we can go one step further. It's not really asked in this question. We can find theta itself. If cos of theta is equal to 2 over 3, then theta is the cos inverse of 2 over 3, and theta would actually be 48 degrees if we were asked to find that. Second type of problem we might come across is where we're asked to solve a right-angled triangles, where we're given an angle, we're given the length of one side, and we might have to find another side. So to find x, just remind ourselves of our trigonometric ratios here, sum old hens, cackle all hours till old age. We can go with the tan of the angle which we know, because that will lead us towards the opposite and the adjacent, and we'll have two knowns and one unknown. So the tan of 32 is the opposite, which is x, okay, over the adjacent, which is 14. That means, if I was to cross multiply, that x is equal to 14 times the tan of 32, and if you do in your calculator 14 times tan 32 close bracket equals, you get 8.75 centimetres, rounded to two decimal places. And the third type of problem then is finding the angle, even though we met this in the first example at the end of it, using the inverse ratios, the sine inverse, cos inverse and tan inverse. So we're given a triangle here, we're given two sides, the hypotenuse 5 and theta, we're looking to find that angle theta. Okay, that can be the angle A, B, C, D, any notation can be used, but generally the mathematical notation for the angle is theta. Okay, so I always write down my sum old hens, cackle all hours till old age, my ratios, and it's really important to name the sides of the triangle you're given with respect to theta, where theta is in the triangle. So for this triangle, the opposite is the side opposite theta. The hypotenuse is always opposite the right angle triangle, and the adjacent side is the one that's touching or beside theta. Okay, so we now know that the opposite to theta is 3 and the hypotenuse is 5, so we can use the ratio sine theta equals opposite over hypotenuse. Sine of theta is equal to 3 over the 5, so therefore theta is equal to the sine inverse of 3 over 5, and that's 37 degrees to the nearest degree. Let's move away from right-angled triangles now for a moment, and let's look at how to find the area of a triangle. So if we're given a triangle and we know the length of two sides, A and B, as well as the size of the angle between the two sides, we can use the formula that the area of that triangle is equal to a half times the length of one side by the length of the other times the sine of the angle in between. Okay? So here's an example here. We have, if the area of the triangle is 40 centimetres, so we're given the area 40 centimetres squared, find the angle A correct to the nearest degree. Okay, so area is given by half this side by that side times sine of A, the angle in between the two sides. So 40 is equal to half 14, 7 times 10 is 70A. So the sine of A is equal to 40 divided by 70. I've divided both sides by 70 there, and the original 70 just cancelled here. So if that's the case, if sine A equals 40 over 70, A must be equal to the sine inverse of 40 over 70. A is equal to 34.85 degrees. It's the nearest degree. A is equal to 35 degrees. So again, we've moved away from right-angled triangles now, and we're looking at the sine rule. And the sine rule, if we take this triangle here, A, B, C, the vertex at A, B, and C, the angle at A is A. The angle at B is B, and the angle at vertex C is C. The sides opposite each vertex and angle, so for this case, the side opposite A is small a, the side opposite B is small b, and the side opposite C is small c. Given all of that, we can use this formula to calculate lengths or angles within the triangle. So we can use, if we're looking to find the length of the side A, B, or C, we can work with A over sine A equals B over sine B equals C over sine C. And if we've 3 pieces of information, we can find the fourth. Okay? If we're looking to find the angle, we can just flip that formula on its head, and we can say that the sine of angle A over small a is equal to the sine of angle B over small b equals sine of angle C over small c. And again, if we have 3 knowns, we can just equate the 3 unknowns and find the fourth. Let's look at an example. So let's say we're given a triangle A, B, C, and we're given the length of AC and the length of BC, and we're given this angle here at A, 71 degrees, and we're asked to find the size of the angle ABC. That's the same as the angle at B. It's always the letter in the middle if you're given an angle with the 3 vertices named. Okay, so we're looking to find this angle here. So how do we do that? Okay, well, the first thing to do is to name our sides. Okay, so the side opposite B is B, and the side opposite A is A, and the side opposite C is C. So we're looking to find sine of B, or B, but we'll go via sine of B. We know what the length of B is, so we have 2 parts that we know. We know what the angle at A is, we can find the sine of A, and we also know what A, the side, is as well. So we know 3 parts, this part, this part, this part, and we can use all of that, or equate all of that together to find sine B, which will help us find B. So B is the side opposite B, it's 15, A is the side opposite 22, so if we plug all that information in, sine B over 15 is equal to sine 71 over 22. Sine B must be, if we cross multiply, equal to 15 times sine 71 all over 22. That's 0.6446. So if sine B equals this, then B equals the sine inverse of this. So that would tell us that B to the nearest degree is 40 degrees. And you know, if you were asked for C, you'd add these 2 up and you take them from 180, and that would give you the value of C there.